Hello, everybody. Thanks for the event and thanks for joining us today. My name, as mentioned, is Priscilla Parodi. Here is my LinkedIn profile in case you want to follow me, talk to me, ask questions after the presentation. Feel free to send me a message. I am a developer advocate, as mentioned, so one of the things I do is to talk to you, to hear you. I'm the bridge between the company and the users, so just feel free to send me a message. It won't be a problem at all with your questions, concerns, and suggestions. This is also my email address, so also feel free to send me an email. Today, we are going to talk about extracting insights from unstructured data, specifically about exploring vector search and NLP in Elasticsearch. So before we get started here, who knows what Elastic is? Cool. Who knows what Elastic is because you've been there and talking to me today? Okay, a few of you, cool. And, well, you all know Elasticsearch. There's that said yes to the previous question. Okay, cool. That's great. So today, this is the agenda here. So we're going to cover data, Elastic, the Elastic Stack, and Elasticsearch for the others, mainly also who doesn't know, but also adding information for the ones who probably heard of it. Then we are going to cover unstructured data and vector search, what vector search is. You're probably hearing about vector search over and over again when it comes to ChatGPT, when it comes to embeddings, etc. So I'm going to cover it. And then we are talking about semantic search versus lexical search, hybrid retrieval, you can see it's a lot, text embedding, and other NLP models. I'm not going that deep into what AI is. I think you've been hearing about what AI is, but AI, ML, deep learning. Just know that when I talk about NLP, it's mainly deep learning plus linguistics. So this is mainly something I'm not going that deep today. And then we are going to cover image similarity and data flow. Everything, of course, considering the aspects of Elasticsearch. So let's get started with a bit of introduction, about a context about data. See if it goes. Well, today we live in an always-on world. From the time we wake up to the time we go to bed, everything we do, or I would say most of it, it's data, and data being generated, data being collected. So if you think of your friends, people you talk to, or people you don't like that much, you just muted them on Instagram. Your favorite songs, the ones you chose to thumbs down, I'm skipping this, bank account, money, crypto, what else? GPS, cameras, even the ones that you don't pay attention, it's over there and it's recording and it's data again, over and over again. And some say data is money, data is the new currency. Well, that's true. This is something. So this is great. As many devices that we have and possibilities that we have, it means storing data. So by storing data, we have this possible money, right? But the point is, with it, there is a real challenge. How to put all this data to really work, to do something with it. What we need is search, and Elastic is, in fact, a search company. Usually when I tell people that Elastic is a search company, they come up with this search box, which is actually one use case, probably because of Google, right? And of course, it's pretty famous. It's a full-text search use case, but actually, search goes beyond full-text search. So let's see some other examples here. Considering Uber, which is one of our customers, usually when you see this GIF here and they're interacting with the app itself, you insert address and then you're well, this is kind of the search experience, right? Because I'm inserting the address, it's a text field, and then this is kind of me interacting with search here. But actually, considering the core of Uber, it goes beyond this first interaction. Actually, the core of Uber when it comes to search are the GPS coordinates that sometimes some of us don't even think about. But it's actually type of data. It's being stored. It's being collected. And if it's not working that well, if it's not properly stored, if it's not working fast, the way that the driver will get all the updates, the person that is waiting for the driver also gets all the updates, it won't work that fast. It won't work that well. And the person will probably just give up and use something else. So one of the reasons why Uber works really well is because it knows how to work with GPS coordinates. There's another app. I was like skipping the introduction here for this one, but some of you, maybe the ones who are not familiar, this is Tinder. Tinder is also one of our customers, and for Tinder, this is also a search use case in the end. So the idea here for Tinder, instead of having GPS coordinate and a lot of address, we have a human database, if you can call it this way. So the idea here is for you to find your perfect match or someone that you want to hang out with, or anyway, a friend, who knows. But the point is, filtering is part of a search experience anyways. So in the end, Tinder is all about search. My point here is, well, why, right? So search is a constant, is a foundation. So as long as you have data, if you have it, if you're storing it, you can definitely search. And if you do this well, it means something. It's kind of like everywhere if you consider. Like I gave you some examples, but actually think of like the back-end aspects of it. Think of like your infrastructure logs. Well, I have like a lot of logs. I'm storing it all, but am I searching it? Do I have like the ability, the capacity to search it real quick? So this is something that you can ask yourself and see if you're doing a great job to have like a good search experience when it comes also to your back end, for example. Well, let's meet, for the ones who don't know, the elastic stack, ELK. For those who know as ELK, I think it's a popular term for. And by the way, there are stickers of ELKs. I don't know if you've been to booth today, but we have like a lot of ELK stickers, so just go there. And yeah, there's some for you. But mainly, we are a way for you to insert data, structure and unstructured, and on purpose highlighted unstructured because this is the topic of the talk today. But a way for you to insert data, store, search, analyze, and then get insights from there. The core of the elastic stack is Elasticsearch. Elasticsearch is mainly a way for you to insert your data, like we have mainly data store. This is not a relational database, so you're not having like the columns, tables, etc. This is not the case here, and you use it as a search engine. So we work with like a variety. That's why we don't call it a database some of the times. We call it as a data store because you can work with a variety of data. So I talked about GPS coordinate, IP address, and here goes including vectors that I'm going to cover later on. But this is mainly the idea of Elasticsearch. And then we have Kibana as what I call the window or the interface, or anyways, the way you want to call it, but to access the Elastic Stack. So mainly from here, you can insert data into the Elastic Stack. And of course, more than this, you can create dashboards, you can create canvas, generate reports, generate alerts, and so on, the way you want to do it. And of course, how do I put data there, right? We have a lot of connections. We have more than 200 connections, so I'm pretty sure you can do something with it. We have MySQL connectors. Well, there's a bunch of them that you can try it out and see how it works and see if it works to your use case. But we have open as a philosophy, so you can also build your own. Well, I talked about unstructured data here, so let's go back to unstructured data. Why search and get insights from unstructured data? I want to share with you some numbers. So first thing, 80 to 90% of data is unstructured data. As expected, right? Because, I mentioned like some data here, like text, audio, when it comes to camera, the video itself. So all of this unstructured. It means that we can't put it like into proper columns, tables. We really don't know. Some of them we don't really know what it is. So we need to like understand it. You need to get a proper value and the proper information for it. And well, that's great. Okay, fine. But this is the most concerned part, which is less than 20% of the organizations reported being able to analyze and take advantage from it. This is a problem, right? Because like we are creating new devices, we are creating, here you go, Alexa, Siri, ChatGPT, all of this stuff, and we are consuming it, we are doing things with it, building applications with it, but are we doing something with it? Like, are we really using all this data. So this is something to pay attention and to ask yourself. Vector search, in fact, improves search, facilitating the extraction of insights from unstructured data. Well, what is vector search, finally? Vector search is a technique to search for similar vector representations of data in the embedding space. I think this phrase is like a bit of complex, but mainly you have the documents, you have all of your unstructured documents, you have vector representations from these documents, you generate these vector representations, and finally, you run what we call a k-nearest neighbor search. Let's cover what it means. How does it work, in fact? So embedding represents data. So here I have one-dimensional space that goes like from one place to the other. Here I'm sharing and using elk again because of the name and because of the stickers we have anyways. This is something that people call the elastic stack. So I'm going from, in one-dimensional space, from realistic to cartoon. So I have a realistic elk, and I have a cartoon version of elk who apparently is studying or reading some stuff. We do have, as I said, like some stickers with elk. It's really fun. But yeah, it's not random that I'm using elk. But yeah, with it, we have like one-dimensional space, but we can keep adding stuff. So multiple dimensions represent different aspects of data. So we're going from realistic to cartoon, and now we're adding also from mammal to bird. And I'm also adding here an owl. And the idea here is, well, you can go same thing. I'm also adding the cartoon for the owl, and then comparing from the realistic owl to the cartoon owl. Fine. And with it, I can keep going, like in terms of like adding data. And in the embedding space is like where the data lives, where this vector representations lives. So in this embedding space, mainly, all of these data are similar, are positioned next to the data that are similar to them. So in this case, for example, when it comes to mammal, but let me put the pointer here. When it comes to mammal, but is also a cartoon, they're like on this side. And when it comes to realistic, but birds here, and then mammal there. So this is mainly like how a vector should work. In fact, I think like as expected. And the point is, this one, I don't know if you ever heard of bits, one of our tools, but it's when elk started fly. Elk is elastic search, log, session, kibana, and then when it inserted bits, it's been like bee. So it started flying, it has wings. So mainly, that's why this is kind of like a mix between a mammal and a bird. This is the intention here. And this is basically what happens with our data once we store these vector representations. They are living, if I can say this way, in the embedding space, one close to the other that is similar to them. And finally, with it, by having this data living similar, close to similar data, we can then perform what we call the vector search. So the vector search finds similar objects as those close to the query. So here we have, again, the student elk, and then the student elk here, the other elks here. And then you have the relevance measured by, as I told you all, how similar one are compared to the other. So they're neighbors. That's where the name comes from. They're neighbors. So as you can imagine, the cartoons are the ones that are closer to the query. So this is how we measure relevance in this case. Okay, fun. But what does vector search allows, in fact? Understood how it works, cool. But what's the point here? It allows semantic search. So this is a thing. If you're used to work with Elasticsearch, you know something that we call traditional text match. What do you call the lexical search? So mainly here, we have like specifically searching, looking for a perfect match in the document. So the idea is we look for a direct match at all the queries in the documents that we have available. And the relevance here is based on the frequency and the rarity of these terms. So as we have there in this example, we have just a phrase. Of course, the way we are matching it, Elastic used BM25 as a ranking model, so utilizing the term frequencies. So the way it does here with lexical search is, well, I'm looking for a match considering these words. So you can have, like, of course, allowance when it comes to fuzziness, like to some simple mistakes and add some synonymous that you already know. But the point is, it will basically look for the terms that are already there, already in a place. And then it will rank the documents based on these terms, considering these terms and looking for the match. But actually, with semantic search, you can go even beyond text match, allowing you what we call a context-aware representation of text, taking into account intent, taking into account ambiguity, taking into account the context itself. What is the intention of the user behind the query? So in this example, I know that you probably already read this example and know it all, but the point is, in this example, if you just read this with me, you can understand the importance of context. So if I started telling you, the man went to the, and I just don't tell you this word, well, I don't know. You probably don't know. The man might be going anywhere, like to his house, anyways, whatever. But if I keep writing here and say, well, he bought something of milk, well, now it makes sense. He bought it from somewhere. And then, of course, like here it might be like grocery store way, but the man went to the store and he bought a gallon of milk. Now everything makes sense. So with it, we can understand the importance of understanding the intent, understanding context behind queries. So if I forget a word here, like for, I will show this for, you probably say like example, for example, because you're kind of like expecting me to tell you this word because you know what it is. So this is the importance of knowing the context of words, of text. So, is semantic search used instead of traditional text search then? Not really, not necessarily, but they can complement each other. So the point here is, if you're already using Elasticsearch, BM25, you're already using these traditional ranking models, well, these are really valid models. It depends on the use case. For example, think of like a short, simple sentence that you already know what it is. You're kind of like expecting the user to tell you something. You already know the content or something about the content. So it's kind of like, well, somehow prepare. It doesn't really matter that much. But then when it comes to a Facebook post or a book or something that might be random and you don't really know what to expect, you don't really know the match, the lexical match that will happen, this is really important, because it will allow you to go beyond and understand the meaning of it. So this is actually the importance of vectors when it comes to semantics. Well, but you can do better. You can do what we call a hybrid retrieval. So you can combine both traditional and vector search. In this example here, let's see if I can use the pointer. What I'm doing here is, for those who don't know Elastic, this is the name of your index, so where your data is living, and we are performing a search, a simple search process. And for the ones who are familiar, this is a query, and we have a match query, the lexical search, as I just mentioned, into this text field name, a good text, anyways, but yeah, the name of our text field, and we put the query string. Okay, what we are looking for, right? The ones that want to match. And here we are performing, as I explained before, the nearest neighbor search. So top K numbers of neighbors that are nearest to the query. So we have the field that contains these vector representations, and we have the query vector, which is in fact the vector that represents the text. And we can run both together, and we can, if do better, we can add what we call boost. So we can like, well, you know what, get this score from the match query and consider it as more relevant, as more important. So I want to put here 0.9. And then for the KNN, just go with 0.1. So this one will be multiplied by the final score. So you are prioritizing this over the other. And then the KNN score multiplied by the boost, you just place it there. And then you have a final score, which is a combination of both. Well, okay, but I talked about inserting your text vector and things like that, but how to actually generate this stuff, like how to actually generate this embeddings. You can apply a text embedding NLP model. With all of the advances, there are different models available, but you can apply it and you can have your vector representation. So here, I have something that I used for the other example, which is mainly you inserting the vector representation of text. You're just inserting the vector, you already have them. You probably have, I don't know, it depends. Maybe if your company is already storing it anyway somewhere, you don't need anything else because it's already there. But what you can also do is you can replace it with what we call in Elastic a vector builder object. And then when you have this vector builder object, you will insert the text embedding NLP model. And in one search request, you will be able to process it all. And in the end, the only data that will change here is the query string. It's like the match query. You are just inserting the query string, and that's it. The model ID will be the ID of your model. That's simple. Well, that's simple, but how? Because you already imported and deployed your text embedding model. So you can deploy your model into Elasticsearch to do that. And for doing that, you can use a pre-trained model, or you can import your own model if you have it, the way you prefer. Well, what I have here, I don't know if you all know Hugging Face. Some of you is familiar with, okay, cool, great. So if you're already familiar with Hugging Face, this is here. Like, we have something that I think will really facilitate your life. So you can just go navigate through Hugging Face. You can filter by your favorite text embedding model. It will be PyTorch trained BERT models, the ones we support. And then by finding your model, you can import it with Elan, which is a Python client that we have. And honestly, the command will be that simple. It will be basically it. You choose it. Here you insert your Elastic cluster URL information. The model ID, in fact, is the title. It's just like copying and pasting the title right here. Once you select your model, and the task type, we are talking about text embedding in this case, it will be text embedding. And that's it. We'll import it. And then once you import it, of course, it will load for a while, I would say, like expect, I don't know, 20 minutes or so. It depends on the model, but just once. Once it's imported, that's it. You're going to store it into what we call the machine learning node. And then once it is stored, you will go through Kibana and find your trained models list. And this will be the ID that I just pasted there in the other slide. Here. Well, actually, in the end, you can apply NLP models beyond text embedding. And I think this is really cool. You can do better and do more beyond the text embedding itself. So you have the option, as we have this support and Elan available, you have the option to actually include other tasks if you want. For those who work, I saw that some of you is familiar with NLP, like good percentage actually. So you already probably use it to sentiment analysis, entity recognition, question answering, and here it goes. We have a list of supported models that you can import and start using it. And this is really cool because once you have it imported, you can just deploy it, start it, and use it from there. You can have all of your REST APIs just leave in there and start consuming it. So as long as you have the ML node and your model is imported, you can just start using it. Well, finally, let's go over image similarity. And I think this is something really cool that vector search also allows. So here, I chose it because I've been to this winery actually, and I think this one is really cool. It's good. So this is a Malbec Trivento. It's from Mendoza, Argentina. It was like years and years ago, but I remember this one because, anyways, I just remember and wanted to use it. But let's consider this, and if you think of like e-commerce, this is kind of like one of the use cases, I would say, very popular for this kind of use case. But of course, you can go beyond. You can consider like other use case depending on what you're looking for. But consider this, we have an input, and then the results are the ones that are, as we just said, the ones that are close to the query in this embedding space. So here, for example, it might be other wines. So we have a bunch of wines. There's one from California, white wine, and there's other two, red wine, Sauvignon. They're both Cabernet Sauvignon. Anyways, wines. It depends on the data we're storing. It depends on the quality of the vectors you're using. Anyways, but in the end, they're kind of like close to each other. That's why they're similar to the query. The query lives probably very, very, very close to that. So what you can also do as an option that I think is really cool is for you to connect text and image. So here you can do better with both, right? You can do better using the natural language understanding of the text with the context understanding of the image. It goes beyond than just describing the image or adding like one or two characteristics of the image. You're kind of like just having like considering all of these details when you are generating vectors of it. So here I am actually looking for, this is kind of a real e-commerce website, by the way. So we're looking for a Malbec wine from Mendoza, and I check it. They're all from Mendoza, red wine, and Malbec. So this is something really cool because by combining both, you can improve the performance. And again, I use it exactly the same website. So this is something searching with an image and searching with text, but considering an image too. So this is something you can do with it, combining both. Well, and how, right? This is one example. I think you'll like to hear that actually OpenAI also has something about it. OpenAI, the ones from ChatGPT, well, they have like a lot of stuff going on. So this is something that is also available. And how? Well, in the end, they're considering what we call image plus text pairs. So they are training it into pairs of text encoders and image encoders here. And this is basically how they are connecting information. So it's not like one thing, not like with the other, two different things connected and being used together. You can just go to GitHub. It's open. If you look for OpenAI Clip, you can import your vectors and start using it. Not really import, but like start using your vectors in Elasticsearch with OpenAI Clip results. Well, in the end, it allows you to search any unstructured data. And this is the point. Here we cover part of the image, documents. Here you go, like audio, something that you want, sensors, etc. Everything you want to add here. And you're going to transform it into embedding. So you have the vector representation, the dense vectors of it. And of course, you have the query on the other side. It might be a natural language data, or it might be, if it is an image, for example, sensor data. Anyways, you have the vector representation directly. You don't need actually to interpret the text data, the raw text data. So you just go directly with the vectors. And in the end, to get your results, you are performing a nearest neighbor search. So this is mainly what you're doing. Vector search powers the next generation of search. So we cover semantic search, vector search plus lots of NLP models, image similarity, and actually any data. Like as long as you have it, you can store it. If you have any questions, or if you want to see a demo, I do have some demonstrations that I can share with all of you. So just go to our booth. I'll be there. We'll be there. I have some people also from Elastic. They're really friendly, and they'll be there with me. So just reach out, talk to me. But if you want to ask questions later on, this is my LinkedIn and my email address. So feel free to test it out, see if it works to your use case, and then we can keep talking. Thank you so much.